I'm Anil Kumar, sharing with you a test problem on characteristics of functions. Normally, in the test papers you'll find a function saying x squared plus y squared equals to 1 and say whether it is a function or not. Well, we know it is a circle with 1 as the radius, and since a circle will fail the vertical line test, we know it is not a function. But how about a function like f of x equals to square root of 1 minus x squared? What is this function? Well, the first question should be, is that a function or not, right? So, if you recognize this, which is x squared plus y squared equals to 1, you can correlate it with this given function, f of x equals to square root of 1 minus x squared. Let's rearrange and then figure it out. So if I rearrange, I get y squared equals to 1 minus x squared and y equals to square root of 1 minus x squared. And remember, whenever you do square root, you have to take both signs plus and minus. Well, since for every value of x, we can get two values of y, which is plus and minus. We know this is not a function, right? And it represents a circle, so of course it is not a function. But this is algebraic proof, which says not a function, right? Not a function. But how about considering just y equals to plus square root of 1 minus x squared? That means we are considering the upper half of a unit circle, right? This is a unit circle. So what we are trying to do here is we're just considering the upper half of a unit circle, right? So we have a circle like this. So we are not considering the whole circle. If I write y equals to plus square root of 1 minus x squared, then what happens? Since we are considering only the upper half, it becomes a function. Do you see that? So if you draw any vertical line test, it will go through only one point, not 2 points, since we are not considering the lower half of the circle. So it is a function. Semicircle is a function, and that is how you can write equation for a semicircle. So this equation represents a semicircle. Now the idea is, if you get it in the test sometimes, it becomes very difficult to correlate. But now I think you can get it, right? So if I give you equation y equals to, instead of 1, if I write 5 minus x squared, that means square root of 5 is the radius, not 5, okay? In this case, square root of 1 is 1, therefore the radius is 1, correct? So that is how you should be looking at it. Now let's explore this semicircle, and I'm calling this as a parent semicircle kind of thing, okay? So graph I've already drawn here for you. It's not so good, but I hope you get it. It's a top half of a circle. Now domain and range. As you can see, the domain is from -1 to 1. So we can write domain as x belongs to real numbers, right? Where x is greater than equal to -1 and less than equals to 1. Now from the equation, how do you get the domain? That is also a very important question to be answered. So I'll leave that part for you. But remember one thing, to answer this question from the equation, how do you get the domain? What you have to do is, you have to say that, well, in that case, 1 minus x squared should be greater than equal to 0, right? Because within square root, we cannot have negative. So 1 minus x squared should be greater than equal to 0, and that will give you this solution that x is between -1 and +1. So algebraically also you can find your domain using this concept, okay? How about the range? Range, we see it is from 0 to 1, so we can say y belongs to real numbers, so that y is greater than equal to 0 but less than 1. So I should have written like this. Let me rewrite this. Y is between 0, including 0, and 1, okay? So that becomes the range for this function. Symmetry. Now we can see it is symmetric about y-axis, so it is even symmetry, right? So this is symmetric about y-axis. So we can say it is even symmetry. So symmetry is even. But if you have to prove it algebraically, then how will you do it? So how will you do it? So what you can do here is you can find what is f of minus x. If I replace x with minus x, what happens? I get 1 minus x whole square, right? So that gives me square root of 1. Minus x whole square will be plus, right? So we have 1 minus x square, and 1 minus x square is f of x, right? So we see f of minus x is same as f of x, and therefore it is even symmetry. So that gives us that answer. Correct? So that is another part of this question which you should understand. X and y intercepts. As you can see, x-intercept is what? X-intercept is a point where y is 0. So to solve algebraically, what we do is we write f of x as 0. So we write 0 equals to square root of 1 minus x square. Correct? Now, if you square it, you get 1 equals to x square. That means x equals to square root of 1 plus and minus, that is plus minus 1. So the x-intercepts are for x equals to plus minus 1. So these are your x-intercepts, correct? So that is how you can get algebraically x-intercepts. Now how about y-intercept? For y-intercept, you have to write x is equal to 0, right? So if I write f0, that means f of 0 is what? That is y-intercept. So we get square root of 1 minus 0 square, which is 1. So the y-intercept is 1. Correct? So that's your y-intercept. Let's look into increasing and decreasing intervals. So the function value increases from minus 1 to 1. Well, I should say from minus 1 to 0. It increases from 0 to 1. And then it decreases from 1 to 0 as we move x value from 0 to 1, right? So increasing is when? So it is increasing when we move from minus 1 to 0. So that is the interval of increasing. So we should write this as minus 1 to 0. And decreasing is from 0 to plus 1. It is decreasing in this interval. Rate of change. We can see that the rate of change is positive in the first half, right? So it's positive here. It's positive but becomes 0 here, right? So from positive it becomes 0. It means what? It is decreasing, correct? And then it becomes negative, negative, and more negative, right? So it is rate of change is always decreasing. What you can do is you can draw a graph for rate of change of a semicircle, right? So that could be another exercise for you to do. With this, I think you must have found semicircle functions very interesting. It's kind of a very important function for you from examination point of view. In many different forms, this question is there for you to answer. So go through this video and answer the questions also in the description. Understand it so that you can do far better. Thank you and all the best.